tight pulley. The rod should be horizontal. That's what he's saying. So when the rod will be horizontal, when the tension set up here, and here tension T1 you take it. What about the tension here? T2. Why I'm taking different tensions? Can you go back to laws of motion? So what are the forces that is acting here? Mg, here it is 2mg. Is it blocks are in equilibrium? Is it possible for m and 2m to be at rest? Cannot happen. No? So what is the state of them? They'll be accelerating. And the string will be taut. And here tension will come here. So it's asking now find the value of m naught for the rod to be horizontal. So for the rod to be horizontal, net torque about O must be 0. And we know T1, X and Y. We don't know T2. Can we calculate T2 from this? So I'll proceed here. So first we'll calculate on the right hand side. 2mg minus T2 by 2 equal to 2m A. Then T2 by 2 minus mg equal to ma. Solving this, we'll get the expression for acceleration as g by 3. Is it agreed? Acceleration. Then I'll substitute the value of this. T2 by 2 minus mg equal to mg by 3. 3, 4, 4, 6. 2 mg by 3. Tension. Eight mg by 3. 8 mg by 3 is what the tension I got it. Now for the rod to be in equilibrium, net torque on the rod must be 0. Then T1 into X will be anti-clockwise. T2 into Y will be clockwise. So we know T1 should be equal to m naught G. Positive, and this should be T2 negative 8 mg by 3 into 1. So what is value of m naught? M naught should be equal to 8 my by 3x. No, sir, how you can say equilibrium? I'm not saying, or I'm saying only equilibrium of the rod. So is it possible a part of system in equilibrium, a part of system in motion? Yes. You can get a system where, see, what is the state of the rod? Rod is in equilibrium. This rod is in equilibrium. What about this pulley and the other thing? The pulley is also in equilibrium. What about the blocks? The blocks are not in equilibrium. So is it possible, sir, a system, a part of system in equilibrium, a part of system not in equilibrium? Yes, it can happen. Nothing is there. So you be careful. Huh? Theoretical question they'll ask you. Is it possible practically a situation where a part of system is in equilibrium and the other remaining part will not be in equilibrium? Yes, it can happen. Blocks are not in equilibrium, whereas the rod plus m naught, pulley, rod and m naught are in equilibrium. Theoretical questions. Until let's see, if you don't have numerical, we can't conclude here. With numerical only, I can conclude all such things.